In this video, we're going to model and solve situations using quadratic equations, but in this video, we're going to focus specifically on what is called vertical motion. So the equation that you see on the screen is the equation that is used for vertical motion, and each portion of this equation represents something different. So h you want to label as the height of your object, whatever it is. So h is the height at the current time. T is the current time that has passed. So when you look at this equation, h is the height, which is the current height at the current time, and t is the time that has passed. Then this v sub 0 really stands for the initial velocity. And what we're going to start with when we're using quadratic equations is we're going to start with an initial velocity that is typically 0. But as we progress and as we learn how to solve more complicated equations, we are going to eventually have an initial velocity. And what that might mean is that the object is being thrown up into the air, or maybe it's forcefully thrown down. For the time being, we're going to have objects that start with a velocity initial of 0, which means they have no motion to start. They basically start from a free fall. They start from nothing, and then their speed gains speed as it goes. That's where we're going to start. We're going to start with these, but eventually we will add a starting velocity. So kind of keep that on your radar. We're going to get to that point eventually. And then h sub 0 is the initial height of the object. So things don't always start with an initial height of 0. Sometimes they start, 100 feet in the air. Maybe sometimes they just start in your hands at 4 feet above the ground, whatever that might be. So we're going to find these items, we're going to fill in what we can, and then we're going to solve and use the equation to our advantage. Now, the only thing you have to realize is that this equation, while we input a lot of numbers, comes with a negative 16 in front of that t squared. And that is never going to change because that is how our acceleration due to gravity works. So we have gravity that exists in our world, and gravity starts to pull things and they start to move faster and faster and faster as they fall. So this negative 16 will always be contained in our equation because that is how acceleration due to gravity, or that is how gravity makes our object move faster and faster and faster as a result of gravity. So let's take a look at this example using vertical motion here. So we know that our vertical motion equation is going to be h equals negative 16 t squared plus our initial velocity times t plus our initial height. So that is the equation that we always start with. Now, if I look in this equation, I see a variety of pieces of information that will be helpful. So it says that it is dropped from a height of 50 feet. So that height of 50 feet is where my egg is going to start. Because this is my starting height, we are going to replace h sub 0 with 50. Now, I also know in this situation that we're going to drop this from free fall. So we're going to start with no movement, which means that this value right here for our v sub 0, or our initial velocity, this value is going to be 0. So we have our equation here, and we can fill in h equals negative 16t squared plus 0t plus 50. And then from here, when I look at this, what I notice is that 0 times anything is 0. So this really doesn't need to be there. And my equation for this particular situation is just negative 16t squared plus 50. So this is my function for this equation. So that's the first piece, right? A function that gives the height in feet of a container after t seconds. And then it says, how long does it take the container to hit the ground? So what I need to do here is I need to think about the ground and what I know about the ground. And I don't know how long it takes to get to the ground, but what I know is that the egg starts 50 feet above the ground. So the ground is really when we hit 0 feet. It's when our height is 0 feet. So what we can do here is we can take our equation and we can actually substitute 0 into that equation for height to find the height when it hits the ground. So we're going to change our h value here to be 0 because we want to find at what time we actually hit the ground, and we hit the ground when we hit 0 feet. So I'm now going to take my example and I'm going to find the time when I hit the ground. Now to solve this equation, I need to get t by itself. So I start by subtracting 50 on each side. So I have negative 50 is equal to negative 16 t squared. Then from here, I need to still get the t alone. So I'm going to divide each side by negative 16. So negative 50 divided by negative 16 is 3.125. And then I know that I need to get t by itself. And in this case, in order to do that, I have to undo the squared, which is going to square root each side. So if I square root 3.125, here I'm not going to worry about simplifying the square root because it's already a decimal. But here we have t is equal to, and remember when we square root a squared, we have plus or minus, and then I'm going to round this to 2 decimal places, or to the nearest hundredth. So I have 1.77 seconds. So that's my answer, is that the time is going to be plus or minus 1.77 seconds. Now, we need to acknowledge that there are 2 answers here. However, we know that in the real world, we don't have a negative 1.77 seconds. We don't go back in time. We only go forward. So here you would say, while I have 2 answers acknowledged here, my time that this egg takes to hit the ground would just be a positive 1.77 seconds. And that's it. So we can use our vertical motion equation, fill in as much as we can find, and then use it to find how long it takes to get to specific heights. And in this specific example, we decided to look at how long it takes to get to a height of 0, which is the ground.